All right, ready to dive deep. We've got this research paper on RWKV-7 Goose, and you want to unpack its learning style.
Yeah, you're curious about this weighted key value evolution, right? How Goose's architecture really makes a difference.
Absolutely. We're essentially talking about how this AI model thinks, remembers, and even forgets. Kind of a big deal.
It is. It all starts with how Goose processes information. Unlike those older transformers, it's not just about step by step.
So Goose is kind of like a high-speed train jumping tracks, making connections across vast distances of data.
That's a great way to put it. It's not just linear processing, it's about connecting the dots, if you will.
I like that, connecting the dots. But the paper specifically mentions this weighted key value evolution. What makes it so special?
Think of it this way. You're reading a news article. You focus on the headline, key facts, a quote that jumps out at you.
Right, you prioritize what seems most important.
Exactly. Goose does something similar. It assigns weights to different pieces of information, highlighting what's key in that context.
Okay, so like a mental highlighter, emphasizing the important stuff. But how does it know what to highlight in the first place?
That's where key value comes in. Imagine tagging information with keywords, then giving each tag a value based on relevance.
So a keyword like international relations gets a high value if the article's about global politics, but not so much if it's sports.
Exactly. It's about context. And here's the cool part, this evolution. These weights and values aren't static. They change as Goose learns.
So it's a dynamic index, constantly updating based on what it's reading, like a library where the books rearrange themselves.
A living, breathing library. That's a great analogy.
Okay, I'm starting to get the picture.
Huh.
But can you give me a real-world example of this weighted key value evolution in action?
Sure. Let's say Goose is reading a detective story. There's a blue scarf mentioned early on, seems like a small detail.
Right, easily overlooked.
But later, that scarf becomes a crucial clue. Goose can then dynamically increase its weight, bringing it to the forefront of its memory.
Wow, so it's like piecing together a puzzle, and the weights show how important each piece is. That's amazing.
It is. This dynamic weighting helps Goose excel with long sequences of information, especially when it needs to remember specific details.
So a much better long-term memory than other AI models. What kind of real-world impact could that have?
Well, imagine an AI assistant that remembers details from your past conversations, tailoring its responses to your specific needs.
So that would be incredible.
Yeah.
An AI that truly understands your history and anticipates what you need. It's like having a real partner in conversation.
That's the kind of personalized, context-aware interaction that Goose's approach enables, but we've only just scratched the surface.
There's so much more to uncover. This whole weighted key value evolution thing, it's fascinating, but I admit, it still feels a bit abstract.
I hear you. We need to get a little more into the technical details. Remember those keys and values?
Yeah, the tags and the relevance scores.
Right. Well, Goose doesn't just store them in a list. It uses something called a matrix to organize them in a much more sophisticated way.
Hold on, a matrix, like from the Matrix. Is Goose going to start dodging bullets next?
Maybe not dodging bullets, but definitely doing some impressive gymnastics with information. A matrix is like a multi-dimensional grid.
So instead of a flat list, it's more like a multi-dimensional map of information.
You got it. This allows Goose to represent the relationships between different keys and values in a much richer way.
And that helps with this weighted key value evolution how?
Think of each key value pair as a coordinate on this map. Goose can then use matrix multiplication to shift and transform those coordinates.
So it's dynamically reweighting the importance of different pieces of information based on the context, like zooming in on certain areas of the map.
Exactly. Less important details fade into the background while the important stuff comes into focus.
That's incredible. So this constant zooming and shifting, that's what allows Goose to excel at tasks like associative recall, right? Remembering specific details from earlier in a long text.
Precisely. It's like having a mental highlighter that knows which parts to emphasize as you read. And this brings us back to those architectural upgrades.
Right, the things that make Goose's weighted key value evolution so effective. So what's so special about this new architecture?
One key innovation is the use of a full matrix linear transition between time steps. This lets Goose look at the entire sequence of information at once.
Instead of reading word by word, it's taking in the whole sentence, understanding the context and relationships between words.
Exactly. Like reading with a wide-angle lens. It allows for much richer interactions between different pieces of information, leading to a deeper understanding.
That's incredible. And this ability to see the big picture, That's what lets Goose make those connections across vast distances of data, like remembering something from the beginning of a book even when you're at the end.
It's like having a mental map of the whole book, with clear paths connecting everything. Goose can navigate the information landscape with amazing speed and accuracy.
This is starting to sound like a real game changer in AI. But are there any limitations to this weighted key value evolution? Are there things it just can't do?
That's a great question. It's incredibly powerful, but still under development. One thing researchers are exploring is how to make it even more efficient.
Because all those matrix operations we talked about, they can be computationally intensive, especially for very long sequences of information.
That's right. It's like having a superpowered brain that needs a lot of energy to run. So researchers are working on optimizing these models.
Streamlining the design, so to speak, getting more power with less energy consumption.
Exactly, making it more sustainable for real-world applications.
That makes a lot of sense. Are there any other areas where Goose could be improved or where more research is needed?
Another exciting area is fine-tuning Goose for specific tasks. Right now, it's amazing at general language understanding and recall.
But to really unleash its potential, researchers need to figure out how to adapt it for specific applications, like translation or question answering.
Precisely. It's like Goose has a natural talent for languages, but it still needs to be trained for specific jobs, learning the nuances of different fields.
This has been an incredibly insightful deep dive into Goose and its weighted key value evolution. It's clear that this technology has the potential to revolutionize the way we interact with AI, but there's still much to explore.
We've only just begun to scratch the surface. I'm really excited to see where this research leads and what the future holds for Goose. Welcome back. So we were talking about Goose's weighted key value evolution and those matrices, right?
Yeah, Goose is like that master chef with the multidimensional spice rack, constantly tweaking the recipe for understanding. But I'm still a bit fuzzy on those matrix operations.
Well, think of each key value pair as a coordinate on this map. Goose uses matrix multiplication to shift and transform those coordinates.
So it's like dynamically reweighting the importance of information based on the context. Kind of like zooming in on certain areas of the map.
Exactly. Those less important details, they sort of fade into the background while the key stuff pops into focus.
And this dynamic zooming and shifting, it's happening all the time as Goose processes new information, right?
Constantly adapting. It's like a living map, always changing with the landscape of knowledge.
So this is how Goose handles tasks like associative recall, remembering details from earlier in a long text.
Exactly. Goose is always updating those weights based on context, so it holds on to those crucial details even across huge amounts of information.
Like having a highlighter that automatically knows what to emphasize. Amazing. So how do those architectural upgrades factor into all of this?
Well, one key innovation is this full matrix linear transition between time steps. It lets Goose look at the entire sequence of information all at once.
Instead of word by word, it's seeing the whole sentence, understanding how those words relate to each other.
Exactly. It's not a narrow view, it's wide angle. This allows for much richer interactions between those pieces of information, leading to a deeper level of understanding.
Wow, that's incredible. So being able to see the whole picture like this, that's how Goose can remember a detail from the first page of a book, even when you're on the last page.
Exactly. It's like Goose has this mental map of the whole book with clear connections between everything. It can navigate information incredibly fast, finding what it needs.
This is really groundbreaking stuff. But I'm wondering, are there any limitations to this approach? What can't Goose do?
That's a great question. While Goose's approach is really powerful, it's still early days. One area researchers are exploring is efficiency. Those matrix operations, they can be computationally expensive.
Right, especially with really long sequences of data. It's like having a powerful engine, but it needs a lot of fuel.
That's a great analogy. Researchers are trying to optimize Goose, making those computations more efficient, but without losing accuracy.
So streamlining the design of that powerful engine so it can go further on less fuel.
Exactly. Making it more practical for real-world use.
That makes sense. Are there any other areas for improvement where further research is needed?
Another area is fine-tuning Goose for specific tasks. Right now, it excels at general language understanding and recall, but to really unlock its full potential.
We need to figure out how to adapt it for specific applications, like translation or question answering.
Exactly. It's like Goose has this natural talent for languages, but it still needs specialized training for specific jobs.
It needs the right tools and training to be a specialist in a certain field.
That's a great way to put it. Researchers are working on developing those specialized training techniques, maybe even tweaking the model's architecture for different tasks. It's exciting stuff.
It really is. It sounds like we're just starting to see what Goose can do. As research progresses, who knows what incredible applications we'll find. So we've talked a lot about what makes Goose special, but every innovation has its limits, right? What's holding Goose back from reaching its full potential?
You're right. It's important to acknowledge the challenges. One is computational cost. Those matrix operations we've discussed, they can be pretty demanding.
Especially when Goose is dealing with a ton of data.
Right. Exactly. Think of it like a high-performance engine. It needs a lot of fuel. So finding ways to make those computations more efficient is key.
So researchers are working on making that engine more fuel efficient, huh?
That's a good way to think about it. More power with less fuel. But there's another aspect that needs attention.
What's that?
Fine-tuning for specific tasks. Right now, Goose is a generalist, great at understanding and remembering, but to truly unlock its potential.
We need to figure out how to tailor it for specific jobs, like translation or answering really complex questions.
Right. Like Goose has this amazing talent for languages, but it needs specialized training to become a master in a particular field.
Kind of like giving it the right tools and training to be a legal expert or a doctor, right?
Exactly. Researchers are exploring ways to make those adaptations, maybe even tweaking Goose's architecture for certain tasks.
That's fascinating. But it makes me think about the bigger picture, As Goose and other AI like it get more advanced, what does that mean for society?
That's a crucial question. These advancements bring both opportunities and challenges. They have the potential to revolutionize so much, from how we work to how we access information.
It's like we're entering a new era where AI can actually augment what humans can do.
Precisely. But we can't forget that AI models are tools. They can be used for good or for bad.
That's a good point.
Yeah.
It's like any powerful technology, right? We need to be careful how we use it.
Exactly. As we develop AI further, we need to consider the ethical implications, make sure it's used responsibly.
That's so important. AI should benefit everyone, not just a select few.
Absolutely. Open discussions about AI are crucial, as is thoughtful research and ethical development practices.
This has been an incredible deep dive into Goose and its potential to reshape the world of AI. From its unique learning approach to its potential impact on society, it's been a fascinating journey.
It really has, and this is just the beginning. I can't wait to see what the future holds for Goose and for AI as a whole.
Me too. It's clear that Goose is a force to be reckoned with, and its evolution will be something to watch closely. Thanks for joining us on this deep dive into the world of weighted key value evolution and the amazing potential of RWKV-7 Goose.